It disappeared. There it is. Okay. All right. As we come to 7.2, let's just sort of go back to one single problem, number 5 from 7.1, because it'll give us sort of the groundwork. So, as we just stated, we have figured out a way to get all the different possible answers from quadratic equations. That's exactly what we wanted to do. We got integer answers, fraction answers, which we could have got by factoring, and some of those that we saw last time we could have, right? We could have factored some of those we couldn't. Let's see, beyond that, now we're able to get square root answers, complex answers, any kind of answers. So we know we've exhausted the realm of possibilities of different types of answers. All right, but we've done it by 7.1, which was this little square root method of solving equations. So before we get to 7.2, let's go back real quickly here to a slide. It's going to be this one here. 7.5. Sorry, 7.1, number 5. You guys remember this one from the other day? It was weird what we had to do, right? We subtracted, we left a little space here. We divided this little number in front, and then this one usually became a fraction. So this, instead of dividing by 2, we multiplied by 1/2, we squared it, added the same thing to the other side, and then got common denominator, simplified as much as we can to a negative 31 over 100, which is right here. And then we took the square root of both sides, and then eventually we wind up with sort of this answer. Okay, so these are numbers here. What we want to do is we want to take it one step further. Instead of using numbers right here, what I want to do is I want to create a general formula. And I think you guys seen it in Math 61. In Math 63, what we want to do is we want to actually create it. We want to see, because in Math 61, I think what typically should happen is that you're just given the formula and this is how you use it. Math 63 takes the approach to say, hey, okay, how did we arrive at this formula? Since you guys are more sophisticated now in your math skills. Okay, so just notice the process. Subtract, leave space, divide by the number in front. Once you do that, take this middle number, divide by 2, square it, add to both sides, simplify, take the square root, add this piece over, and you're done. We good? So we'll get to that in just a second here, but this is from the textbook here, and just see if you can follow along. If you can follow along, that's exactly what you want to do. So now we want to create a formula. Forget about doing that whole process, because yesterday was just a process. You subtracted, you took half of the middle number, you did all that stuff, and it was a process of many, many steps. But the whole point here is to create a formula. So see if you can follow the steps from the numbers from number 5. So subtract the c over, leave just a little bit of space. Hey, look at this. See this little number in front of x squared? We should divide by a everywhere. Kind of feels weird to divide by a. So divide by a here leaves the x squared alone. Divide by a here gives you b over a. Divide by a here gives you negative c over a. We good? And then what we do is we take this little b over a and we divide it by 2, or multiply by 1/2. Gets you b over 2a. Everybody agreed there? We take this b over 2a, so we square it on both sides. Kind of fun little process there. And now we have to take a little time to simplify all this out. So squaring all this becomes b squared 4a squared. Putting together a common denominator. Again, this is on page 437 if you haven't noticed in your textbook. But I just want to run it through with you guys here. Get a common denominator, finally add it up, and you get something that looks like this. And then we don't really like the negative in front, so what we do is we put that little b in the front, and then we put the minus 4ac in the back, just to make it look nicer. This is kind of like number 5, how we got the 31 over 100. Right? We're at that step now. And then we plug it back in. So now this whole piece here has become this right here in simplest form. So we get back to our problem here and see if this makes sense here. This becomes the x because of the x squared. It's a plus sign, remember that, because the signs follow each other. Plus sign, and then b over 2a being squared now is really just b over 2a as a term inside the binomial. take a square root of both sides. There's your little plus or minus, and then we're going to subtract b over 2a over to the other side, and voila. And then you guys should be saying like, I can't believe this is so awesome. So instead of using the process from 7.1, which was sometimes a 5-step process, sometimes a 10-step process, if you needed the common denominators, now we just have a single little formula. All I got to know is what is a b, what is an a, what is a c, and plug it in, and I'm done. So let's regroup just a little bit here, because someone yesterday said, Mr. H, but I can factor, right? And I said, okay, yeah. We look at a problem, if we can factor it right away, we use factoring. If not, I told you, then you have to use this process. So look at something, if you can factor it. If not, then use this little process. Well, not really. We're going to change that up from yesterday's lecture. We're going to say, you're going to factor it, if you can factor it. And if not, then we're going to use this formula, because a formula is a whole bunch better than using a 10-step process. Are we good? Now the question is, Mr. H, why in the world do you drudge us through 7.1? So the completing the square, that sort of process, we will see later on when we start graphing. We still need that process. There's times where we still use it. Particularly, there's 2 different times in higher mathematics where we use it. Graphing parabolas, we have to still understand this little process of completing the square, and then higher on in calculus. Okay, so we got it. We got ourselves a formula. I love it. Okay, what is the formula? Go back up to here now. Now 7.1, that's where we finally start. The formula is, and I don't know why you booked at it. It broke it up into 2 different formulas. We hardly ever do it that way. They're just trying to tell you, really, there's 2 different answers here. There's a negative b plus the rest of it. There's a negative b minus the rest of it. But for the quadratic formula to work, what we have to do is we have to set this trinomial equal to 0. And if we do that, then we just pick our a, b, and c, and we're good to go. The way you're normally seen is this right here. It's negative b plus or minus square root of b squared minus 4ac over 2a. And then the question is, Mr. H, when am I ever going to use it? Well, I have to tell you the story, of course. It just might come in handy. This is, I'll tell you how old I am at this point too. So I went to go rent a movie at Blockbusters. Do they exist? Is there a Blockbusters anywhere in the United States anymore? Okay, barely. Okay. And so I come there, and I'm just about to pay for my movie, and the manager's there, and she's trying to work out a math problem and all that stuff, and so she's complaining, and she's like, oh, what's that stupid formula? It's a dumb formula that says, like, oh, I can get the answer to. I said, oh, that's easy. It's negative b plus or minus square root of b squared minus 4ac over 2a. She's like, well, what did you say? So yeah, it's just negative b plus or minus square root of b squared minus 4ac over 2a. Oh, awesome. So she writes down the formula real quick here. And then she says, dude, you want to rent 2 more movies? I'll give them to you for free. So, see, it may be profitable to know something sometimes, okay? Just saying. Okay, so let's start with it. This is the quadratic formula. Again, you've seen it in Math 61. Math 63, we want to see the why it came about. That's kind of, and of course, we're going to use it. All right, so now let's begin. Example 1, just to get us going. This is from the textbook here. What we do is we set it equal to 0 first. We got to do that first. We grab our a, b, and c. A is the number in front of x squared. B is the number by the x, and c is the loner number. So a is 1, b is negative 5, c is negative 6. And we plug it in, and the only few things here that students mess up on, notice the formula is a negative already. It's a negative of the b. So if the b value itself is negative, you got negative of a negative, which is a positive. A few other things here. What should we notice here? Whenever you're multiplying on the inside, you got to multiply that 4 times a times c first, and then you're going to subtract that from the b squared value. So kind of be careful there. And then, right, as soon as we do it, split it off in 2 different pieces if you need to, at least in your head, and solve each of those, and we're good to go. Okay, so that is, again, that's from the textbook. Don't need to go over that, but let's go with practice problems now. All right, let's go with a is equal to 6. Hopefully you guys got that. How about b is equal to 7 and c equals 2? Good there. And again, if you need to write down the formula, and again, I think this part's easy. I think we have learned that from Math 61 already. More like a refresher. And of course, we're going to put in fractions into this because we've got to take it to the next level, of course. All right, plug into the formula. Again, I'm going to rewrite the formula just in case we got it. In case we need to see it again. So how about negative 7 plus or minus? And some of you guys are doing this already here. Okay, a few mistakes that I really see students make with this here real quick here. Notice right over here, I put my bar my bar line and my square root line when I put in the 2 stacked in a little bit over. So keep on extending this bar line until everything fits. Keep on extending the square root line until everything fits underneath it, because that's somewhat important here. All right, 2 times a. All right, second thing is probably off to the side, just simplify all the stuff inside the square root first. So you don't have to keep on rewriting the problem here. Let's see, 4 times 6 is 24. 24 times 2 is 48. And 48 subtract from 49. I think that should give you a 1. And square root of 1 is a 1. That's nice. And now we have to split off 2 different pieces because we are going to get 2 different answers here. So negative 7 plus 1 is a negative 6. Negative 6 divided by 12, how about as a negative 1/2? Negative 7 minus 1 is negative 8. And negative 8 divided by 12. Anybody with that one? Negative 8 divided by 12. What would be the reduced fraction? I'll go with that. Yep. Negative 2/3 as that final answer. Okay, so of course number 1 is just a refresher for Math 61. The rest of them are going to be sort of the next level up. So these ones you've not seen in Math 61. This is sort of a Math 63 sort of caliber. And we'll start off with fractions. So if I plug in 1/2 for A, 1 for B, and then a 1/3 for C, I'm going to have some trouble. I'm going to have to deal with fractions, and that's not something I want to deal with. So in this case, you know what? Before we do anything else, let's get rid of the fractions. What should we multiply by? 6 is good. Yep, let's multiply both sides by 6. Let me rewrite the problem here. And voila, love it. I love to get rid of fractions. Except not on your exams. I love to put in fractions on the exams. Alright, so hopefully multiplied by 6 here. You guys are sophisticated Math 63 students. You guys can do this here. 3x squared plus 6x, and the other side is going to be a 2. Subtract the 2 off. Again, have to set it equal to 0 before we get our a, b, and c. And again, if you want to label the a, b, and c, go for it. If you just want to start putting into the quadratic formula, go for it. Whatever you like. I'm going to label them just so we can use them later so you guys can see the board if need be here. So I got A is 3, B is 6, and C is negative 2. As you guys are doing that, let me give you a little bit of a discussion. Why are we able to multiply by 6 in the first place? Is because remember the multiplicative rule for equality, right? I can multiply, as long as I multiply the same number on both sides, I technically still keep the equations the same. And so we call them equivalent equations. Alright, let's see, give you a little hint here. If you get somewhere inside your problem, if you still have a square root of 15 in there somewhere, you're doing good. Alright, and I'm going to go with the answer here, look up just to see if you guys are done, or look up when you're done, see if we match. Something about -6 plus or minus 2 root 15 over 6. So again, my question to you, of course, is any questions here off of this one here? Ooh, I got another question here. How many read ahead prior to coming to class today? One? Not sure if you did or not?
Well, technically an upgrade we did.
Oh, okay, cool. Those who went to upgrade, you guys did. Yeah, yes, you can raise your hand if you went to upgrade. Okay, so 1, 2, 3, 4, 5. Oh, wow. We have a record. Okay. Something I want to mention here, and kind of important, this is not the final answer. If you got to this is not the end, because we can still simplify this some more. So let me give you 2 different ways. You tell me which one you like better, okay? So let's go with, let me just rewrite the problem here so we got it. So notice that little 6 on top, 2 on top. Notice these, something could be factored out, is that right? There's a factorable form that could reduce with the bottom. So how about a 2? Would 2 go into 6 and 2? So 2 would go on the outside. Then we left over -3 plus or minus, let's see, 2 goes out. So root 15 over 3, or no, over 6 so far. So yes, you got to put it into the most simplest form, just like we do with any fractions. The 2 and the 6 have to reduce. So then final answer here should be -3 plus or minus root 15 over 3. That is the final form. Sorry, just wanted to get all of you guys over here first. Okay.
Can you go back to your
Previous slide?
Yeah, previous slide.
Sure. Let me go back to the previous slide real quickly here. That was still finishing up. Any questions on the previous slide? Okay, good. Yep. No, just wondering. Yeah, but want to make sure we took the time to get there. And this one now. Okay, now we're good? Okay, this is the correct mathematical way of doing it. So this is when we factor out the common factor, and then since this is multiplication now we can cancel those off because 2 is multiplying that term and everything's a multiplication division. Okay, of course the shortcut, got to give you a little quick shortcut. Shortcut is this right here. If you look at these problems here, what we're going to do is we're going to look at these numbers and we're going to see if we can reduce 1, 2, 3, all 3 of them at the same time. That's all we do. And again, it's almost like the same thing. It's not sort of mathematically correct now, but it's at least a little shorter way. So what's the number goes into 6 and into 2 and into 6? 2. So what we do is we divide the 6 by 2, the 2 by 2, and the 6 by 2. And voila, how about a -3 plus or minus root 15 over 3? Does that make sense? Good? Okay, got about 3 people still writing it down. Again, tell me if there's some confusion there, or tell me if it went the wrong way, or what's up. Okay, not talking to me. Okay, fine. Let's jump to number 3. Now we got rational equations. Oh boy. And let's see, if we go back in our mind all the way to chapter 5, what happened, we were solving these in chapter 5, but whenever we multiplied by the common denominator, it worked out so well that they were able to be factored. That's kind of the difference here. The difference now is, now we're looking at these type of problems. We are going to multiply by the common denominator. We're going to do exactly what we did in chapter 5. But when we get to the solving step, it's not going to factor now. So I've got to use some other means to do so. So let's go for it here. So I guess we should do this here first, because we did this in chapter 5. A little question for you guys. What numbers can we not accept? Off to the side here, x cannot equal -4. Perfect. Again, because you have variables in your denominator, you figure all the different ways I can get zeros in my denominator. So if x is -4, -4 plus 4 is a 0, then I get 1 over 0, and that does not make sense. Anybody, and any other number? -2. I think -2 is going to work over here. If I put a -2 in here, that's going to be a 1 over -2, and that's a 1/2. Zero is the problem, right? Because look at this. This is x all by itself. So this x becomes a 0. We got 1 over 0. We got the same problem here. So final answer, we would not accept a -4 or a 0. So off to the side. Keep it there. Just kind of think in your mind. Let's see if the book talks about it or not. Nah. Okay. All right, give me the common denominator. Common denominator is? Not all at once. Just saying. Two. Go ahead. Anything else?
4.
Not the 4, because the 4 is not by itself. Yep. I need the 2. I need the x plus 4, and anything else. Yeah, I still need this x. Because remember, this is its own little term, right? X is its own little term, the 2 is its own little term, and x plus 4 its own little term. So we're going to multiply the 1 over x plus 4, and again, we're going to multiply x plus 4 times x times 2. And we're going to do that to each and every single term here. Technically, we're just doing the multiplicative property of equality, right? We're just multiplying both sides by the same number. It's just a lot easier to look at it as we multiply each individual term. All right, x plus 4's are gone because they cancel. That's the whole point here. So x times 2 times 1, 2x by me. Cool. Careful, we talked about this the other day here. This little minus sign right here. That's what was wrong on the test last time. Careful when you have a minus sign, because that minus sign has to be distributed. So when the x cancels, you got a -2 still multiplying x plus 4. So this -2 is going to come across. All right, the other side, the 2's cancel, and now I got x times x plus 4. All right, distributing the -2 over, so -2x, and how about a -8? Distributing the x gives you x squared plus 4x. All right, gathering together any like terms that we can or need to put together. Yeah, the 2x's. 2x's on the left cancel. And let's just simplify. Let's set it equal to 0. Are we okay with just adding 8? Doesn't matter which side the 0 is on anyway, so who cares? So 0 is equal to x squared plus 4x plus 8. Okay, now real quick here before we do anything else. In your mind, can we factor? Is that factorable? Can I factor this guy down? Absolutely not. Check the numbers here. How do you get 8? I can't, huh? Bummer. Because 8 is maybe like 8 times 1, and then that 9 has to be in the middle. Or 2 times 4, but then the 6 would have to be in the middle for it to be factorable, right? This is one of those good ones where it almost, at first look, it feels like, yeah, it's going to factor. Of course, it's 8 and a 4. And then when you look at it, like, yeah. Okay, not factorable. Therefore, quadratic formula. Go for it. A is 1. B is 4. And C is 8. All right, give you guys a little bit of time to go for it. Try it yourself. All right, and again, let me just look up if you are done or finishing up before me here. Plug it into the quadratic formula. Just kind of making sure we have the same stuff. And so inside the square root, initially I have a negative 16. Ooh, therefore I know I'm going to have a complex answer here. And let's see, negatives in there, so I gets to go out. 16 is a perfect square. How about 4i over 2? And then can you reduce that some more? Yeah, just divide everything by 2. That's the easiest way to do it, as opposed to writing a whole other step about factoring. But at the same time here on the bottom, that 2 divided by 2 is just going to 1. That means that's a whole piece. There's no other pieces to it here. So how about negative 2 plus or minus 2i? As a final answer, of course, quick show of hands. How many got that before I did it? 1, 2, 3. 3. All right. All right. So now let's go a little bit higher, complex, higher order here. So far we knew the quadratic formula. Let's jump to a cubic formula. Let's see if we can actually solve this all the way through. Just stretching those brain muscles here. That's what we're doing.
Can you use the formula for the difference?
Yep, here's where a little problem. When you say quadratic formula, you mean something squared, right? This is t cubed. Bummer. But hold on, do we know of a formula that's the difference of 2 cubes? I think we know it. Look it up if you have to here, but remember we would say is, okay, what is being cubed over here to give you 8t cubed? 2t. What's being cubed over here to give you 27? Awesome. And this is the difference formula, right? Difference formula of 2 cubes. Again, look it up if you have to. It's inside the textbook here. And so what I'm going to do is I'm going to write 2t minus 3. It's the same terms without being cubed. So it's 2t minus 3. And the formula does make sense quite a bit. So in order to get an 8t cubed, then you already have a 2t here. Don't you need a 4t squared? I mean, the first term makes sense right away. To cancel off the middles, what you need is you need an opposite sign. So you get a plus sign instead of the minus sign in the other. And the only middle one's the weird one. The middle one is you multiply these guys together. So 2t times 3 is 6t. All right, in order to get the 27, of course, you have to have, first of all, a plus sign, because you're multiplying by negative 3. And you have to have a 9 to get you that negative 27. We're good? The formula, as you look at it, especially as we think about it, what numbers need to be there, it should make sense. Okay, so we've seen this before. And we've factored this before. But we've never solved an equation with it before. The reason for it is because this part right here, we did not know how to handle this part yet. Now we're able to do so. This stuff, that's easy, right? You set this guy 2t minus 3 is equal to 0. That's the easy part. The not so easy part is this trinomial that's left over. All right, and this trinomial does not factor down, or else we would have been factoring this down all the way in chapter 1.4. All right, so let's handle this first part here. Everybody okay with this being a 3/2? Add 3, divide by 2. Looking at this one here, does it factor? No. So if it doesn't, then let's solve it. Okay, since a variable is a t, we better write t now instead of x. There's no x here. All right, let me give you the start of the quadratic formula. It's negative b plus or minus b being squared, which is 36, minus 4 times a times c all over 2a. So I'll let you guys finish that up. All right, and let me simplify it out and just see if we agree here. Inside the square root becomes a negative 108. And then we have some dealings with that here. What I got is I got a 6 times 6 is a 36. 36 times 3 gives you 108. So the 6 came out as a perfect square. 8 on the bottom. And of course we do have to reduce the other 6 and the 8. So final answer that I got here, negative 3 plus or minus 3i root 3 divided by 4. Okay, good. I think everybody's done. Tell me if you're not. Okay. As far as solving equations, there it is. We've got it here. We got this quadratic formula, practiced with it, and we practiced sort of four different variations in the process here. So let's jump, of course, to the word problems here. See if it makes sense of this. So object is thrown upwards with the initial velocity of 32 feet per second. It rises and falls according to the equation. There it is. S is the height of the object above the ground. T is the time. So at what times will the object be 12 feet above the ground? So this 32 really comes from over here. This is 32 right from here. The 16 is actually a constant because of gravity. And that's why the 16 is always there. You'll always find a 16. But this is the formula for height of this particular object. There's a more general formula as well. So we're really doing a physics problem here. So something goes up into the air, maybe hopefully comes back down, and trying to figure out where it's going to hit 12 feet above the ground. So let's do this here. Let's just set 12 equal to all that. Alright, and first things first, again, I'm going to do it with you guys here because there's a few little things here that we got to think about. Everybody hopefully subtracted 12 from both sides, is that right? I'm going to put the 0 in that end because I don't like it that way. And then I'm going to write it in standard form, which means I'm going to take the higher power t first and then go lower and lower on the degrees. Okay, let's think about this here for a little bit here. Got myself a little problem. First of all, I see a negative in front of t squared, and that's okay. I could use a negative for my a value. That's okay too. But my real problem is this. Numbers are huge. I'm going to take 32 and I'm going to square 32. It's going to be 900 something or other. I'm going to mess with that. I don't think so. So is there a number that can go into 16, 32, and 12 before it was 4? Okay. We can write. Let's do it by 4. And then you know what? I don't like it. Still, I don't like it to be negative. You know, I can plug in negatives. I'd rather have it to be a positive. So let's divide through by -4, and that way it'll just sort of give us easier numbers to deal with and in the right sort of sign way that we're used to. All right, so I got 0 is equal to 4t squared, much like this. -8t, yep, plus 3. A lot easier to deal with, a lot easier to work with. All right, it's all yours to plug into the quadratic formula. Alright, I'm going to leave the answer up here. Just kind of, as soon as you finish it off, think you've got it, then look up. Otherwise, just try it yourself here. Alright, so let's go for it here. So hopefully you guys got to this step here. Any questions so far by the time we get to the end here? So I want you guys to make use of these numbers. What in the world is 3 halves and 1/2? Can you put it into an English sentence that makes sense for the units and the numbers themselves? That's what I need. This is what I got here. So let's see, at what times will the object be 12 feet above the ground? At half a second and 1.5 seconds. Will that work? So that'll be a statement in English. All right, good. What else is there? Oh, the graphic to it, right? So let's just say this one is someone throwing a ball into the air. So the ball would go like this as it leaves the hand of the guy. It goes up like this and then comes back down. And so 12 feet maybe like right here. So as it went up, it took half a second to go up right here because the velocity was so fast, so high. And then as it topped off, then it came back down. Took about a second to go from here to here. And there's your 1.5 seconds, and then it eventually fell back to the ground, probably right in 2 seconds later. So not that high. Okay, of course, another one here. So business example here. So a company produces and sells copies of an accounting program for home computers. If it's the beginning of the year, I would have said TurboTax, but that's a little different already. The total weekly profit in dollars of X copies of the program. So how many copies must be sold for its weekly profit to be 1,320? So again, we talked about this in class. It's not so much how expensive something is, how cheap, it's just how many can you sell, because it's really price times how many you sold. So it's really about volume. It's not so much about just price or quantity. They together. Okay, got a decimal in here too. We've got to deal with that as well. So let's see, how many copies must be sold for its weekly profit to be 1,320? So here's a formula. So imagine if this is the profit formula. We're going to plug in the 1,320 right into the profit symbol. And then we have the rest of the formula to deal with. Okay, very similar like the previous problem here. So set it equal to 0 first here. So let's subtract 1320. We get ourselves a negative 1820 now, plus 27x minus 0.1 x squared. All right, don't like it to see it that way. Like to see it the other way. So I'm going to write it in standard form. The highest degree on the x goes first, so negative 0.1 x squared, then the 27x, then the minus 1820, just so we're all in order there. Okay, this is the same thing as the last problem here. What should I multiply by so that I can get rid of the decimal, because I really don't want to work with decimals inside the quadratic formula. Also to get rid of a little negative in front of x squared. Negative 10 is perfect. Let's multiply both sides by negative 10. So that just becomes an x squared. Now this becomes a negative 270. Yes, we do have big numbers here. So 18,200. Yes, we're going to have to deal with something here. Maybe use a calculator to finish off the homework. I would say yes, especially with humongous numbers like that. You'll see it does come out nice. So. All right, quadratic formula. And let me maybe do this here because of, let me plug this in here. This is going to be 270 squared minus 4 times 1 times 18,200 all over 2 times 1. Alright, I do not want you guys to get bogged down with the math behind it here. That's not what I'm sort of wanting to do. I want you sort of so you see the flow of things here. Alright, so 270. Doing this a little earlier here. Turns out to be that is exactly at 100 inside here. So square root of 100 just becomes a nice old 10. Just love it when numbers work out that way. Alright, so that's kind of, well, let's get to the answers, then we'll sort of see if it's weird or not here. So 720 plus 10 is 270 plus 10 is 280. 280 divided by 2 is 140. 270 minus 10 is 260 divided by 2 makes 130. So again, all yours. English sentence that make sense of the numbers. Alright, how about, let's see, the question is, how many copies must be sold for its weekly profit to be 1,320? So we must sell either 140 or 130 to make a profit. So that's kind of weird, isn't it? That means there's two different prices that will determine that. And if you think about economics and stuff like that, you guys know something about demand and supply, is that right? As you increase the price, there'll be less demand for it. As you decrease the price, more people are willing to buy. So this formula here, let me just kind of jump, maybe not draw that out here, but this formula is actually a parabola. It's kind of like a down parabola. Kind of looks like this. Oh, I'm sorry, should hit the 0 here like this. So it's saying that at 130, you're going to reach the same amount of volume as you do if you sell 140, just because of the increase in price or the lessening of price. So that's why you have an item that comes in because it's a new item, everybody wants it, so there's this sort of like volume of people buying just because it's new. Then you have, of course, right after that comes the sale price. So then people are buying it, it's still new, but there's a sale on it, so people are willing to buy it. It's the first people that did not buy it earlier. Does that make sense? It's a whole new sector of people that are now willing to buy this product. And then maybe it's a 20% off. Then it goes on to like a 40% off. So then you got, again, a whole sort of this extra stream of volume of people that have not bought it but would buy it at this price range. And then it goes on to a clearance rack, right? Because you have those people that are willing to buy it at a certain price. So it's kind of interesting. Did I tell you this before? Is this a deja vu or no? So something comes in as a new item, and it's really about this. It's really about maximizing profits. So here it is just because it's new. And then they're not going to let this go down over here because there's no profits anymore. So the curve doesn't do that. The curve usually goes like this. Comes up like this. As soon as it hits a certain level, and it's the financial analysts of a company that say, oh, time to put it on sale. And it's a ding, it goes on sale. There's your 20% off sale. And they're not gonna let it go down the bottom. They're gonna stop right here and say, okay, it's still new of a product, but those people are not willing to pay that price anymore. So there's your 40% off, And then at that point, then it goes on to a clearance rack, which is, again, there's still a market for that. So a life cycle, let's say, of a shirt is hitting those maximized volume points throughout the life cycle of a shirt or of pants or whatever. Cool. Kind of interesting how that sort of happens. Okay, with that, let's jump to 7.3. So we've got a few more little things to think about. Since we discovered the quadratic formula, let's sort of think about the quadratic formula. Some things you probably would understand already, like, oh, Mr. H, that makes sense. We're just going to make sure that's more explicit here. So in this section, we'll do two things. First, we'll define something called the discriminant. What in the world is a discriminant? And then based upon that, we will think about what kinds of solutions does this quadratic equation have. And I think you guys already know this, but we're just going to make it really more explicit here. So this quadratic formula, what determines right here if it's going to have a square root as the final answer or no square root in the final answer? Isn't this part right here, is that right? If this turns out to be a perfect square like 16, then voila, there's no square root in the final answer, right? And if it was 15, we got ourselves a square root of 15 in there. There's no way to simplify that. What will determine if that is a complex answer or a real answer? Anybody there? That's a little toughy one. Oh, cool, yeah, it's either positive or negative, right? If it's negative, you know it's complex. If it's positive, you know it's a real answer. So this little part right here inside is very important. We give it a little name here. We call it the discriminant. It's big D, if you want to say it. Okay, big D. B squared minus 4AC. And this is page 447. If you want to turn to it just so you see it in front of you, if you like. And so, yeah, we sort of already said it here. We look at this, just the stuff inside. If it's negative, we know right away it has two complex solutions. We know that eventually when we get to this answer, it's going to have a complex answer. If it's exactly 0, that little plus or minus goes away. Real quick here, let me see. Let me go back to this one right here. If this stuff is 0, notice the plus or minus goes away too. And if all this went away, guess what? How many answers are here now? Ah, now there's only one answer, right? It's just negative b over 2a. There's no plus or minus in here anymore. So because of that, I'm going to jump in between two slides here. So if it's 0, we know we have just one rational solution. And again, remember, rational just means it could be a fraction, could be an integer, could be a whole number, right? Rational incorporates all those words. Okay, if it's positive, but it's also a perfect square, then we know we don't need a square root in there, so we call it two rational solutions. All right, if it's positive, but it really is not a perfect square, the difference between 16 and 15, right? The 16 would not have a square root in there. The square root of 15 then would have, so we call it two irrational solutions. You know, you're gonna have some. Okay, why is this sort of important? Like, this is the way I do. This is the way whenever I need to solve a quadratic equation, I'll do this first off to the side, because if I do that, pretty much almost my whole entire quadratic formula is done, and then I also know what type of solution I have. We're good? So it sort of gives me some information beforehand. Also, if I do this, as we're going to start graphing, once I figure this out, I'll know whether I have x-intercepts or not. So this type of answer is going to help us a little bit later on. Maybe we should connect 7.5 today too. That would be good. Okay, so let's go for it here. So don't want to solve it. Just give me the number and just give me the kind of solution we expect out of this. So let's do this together here. So it's set equal to 0. That's great, because that means I have my A, I have my B, I have my C already, and I'm going to put this in right into the discriminant. So b squared minus 4ac, just figuring that out right there. Alright, so negative 3 goes in for the b, minus 4 times 1 times the negative 28. How about a 9? How about a plus this time, right? Plus. Anybody know 4 times 28? I go with 112. Yep, plus 112. Okay, add that guy together, so it makes one. Ooh, cool. All right, 121. Based upon the number, what do you guys say? What kind of answers? 2 complex solutions, 1 rational solution, 2 rational solutions, or 2 irrational solutions? Perfect. Yep, you got it. 2 rational solutions because 121 is a perfect square of 11. So we know that the square root of 121 will disappear as our final answer. Okay, why is there a distinction between rational, irrational? With rational solutions, I get to know the exact point where it's going to cross the x-intercept. And then again, I'm sort of forcing the graphing on you already here because we get to 7.5. If it's an irrational solution, then what we're doing is we're approximating the x-intercept. That's why. So it's really a difference between exact answers and approximate answers. Okay, next one, all yours. Give me the kind of solution. Don't solve it, but just the kind of solution. All right, and hopefully we plugged in the, as already said, equal to 0, hopefully plugged into the discriminant, and voila, got ourselves a 0. So that means the whole entire square root stuff goes away in the back. So how about 1 rational solution? Okay, why is this important? Because we know it crosses the x-intercept at exactly 1 point only. Again, more on that later.
So will that be just like a straight line? It's not gravel?
No, we'll see. We'll see how that works. More to come, or to be continued, or something like that. Okay, number 3, all yours. Of course, these are just different types. And kind of funny, you know. There's 4 different categories, right? So I bet you there's 4 different problems. Let's just see each one here. All right, plug it in. 4 minus 48 makes a negative 44. At that point, you can really just stop there. It doesn't really matter whether the 44, the number itself, is a perfect square or not. At that point, it doesn't matter because you know it's a complex answer. So 2 complex solutions, no matter if it's perfect square or not. It doesn't matter at this point.
So if it's a negative, then no matter what, it's really, I mean, it's 2 complex solutions.
Absolutely, yeah. Once you see a negative in the discriminant, you don't care if it's perfect square or not. You just know you're going to have an I somewhere there. All right, and number 5. Oh, sorry, number 4. Sorry, I didn't get there yet. Number 4. I'll give you a hint. Something about moving things over to set equal to 0 before you do anything else. Alright, hopefully you guys that. Set equal to 0, x squared minus 4x plus 1 equal to 0. Plug it into the discriminant, and we get ourselves a 12. Okay, it's a positive but not a perfect square, so how about 2 irrational solutions? And again, if you think about it here, once we take a square root of 12, it's really going to be 2 root 3, and you got that little root 3 in there. That's going to be still there. Okay, keep on going. I'm going to go just a little bit faster here so we can get out to time here. Two different things, two more things we've got to deal with here. One is sort of like this little concept, do you understand it? And so find k. So, oh, we got a little problem here. I got a, this is equal to this, equal to that. I don't think so. So on your match problems here, there's something wrong here. This guy should just be a minus. Should be 9x squared minus k x equal to negative 4. So 9x squared minus kx equal to negative 4. Okay, a little bit slightly different problem here. Now we're trying to find the k value. And we want to set it up so that we have exactly one rational solution. Ooh, kind of just a different mindset. It's almost like a solve the mystery sort of mindset. So now we're missing the b value. That's what we're missing. We don't know what the b value is, and we're trying to figure out the b value based upon what we want it to happen. So more like an algebra in this stuff. So first things first, let's set equal to 0. So let's add 4 to both sides. So how about a 9x squared minus kx plus 4 equals 0. Okay, at the end, I need to know what in the world k is. But I want this equation to have exactly one rational solution. Hey, hold on real quick here. Go back in your notes here. When do we have one rational solution? What does the discriminant have to equal? 0. So let's do that. Let's plug in the discriminant. And we're going to set the discriminant equal to 0. So the b comes in as the k now, so that's, or actually comes in as a negative k even, because of the negative there. Minus 4 times the a, which is 9, times c, which is 4. And I'm trying to solve this guy. Whew. All right, negative k times negative k. K squared. All that good stuff over there. 4 times 9 times 4. And 144 is good. Okay, can you solve for k? Yeah, it's factorable, right? So don't need to do this quadratic formula because we know this one. This one factors down into k plus 12, k minus 12, so therefore k is equal to either a negative 12 or a positive 12. Both things would work, which is kind of weird. What do you mean both things will work? So let's talk about it here in a second. So now, Nick, to answer your question, what does it actually mean to have one rational solution? It just means that this parabola is going to cross the x-axis at only one point. That's kind of what it means. So if I drew a parabola like this, I have to, we'll get to 7.5 in just a little bit, but just a quick preview here. The parabola is going to go like this. It's going to cross. Notice it's crossing at just one single point. It touches and then it goes back up. So it's saying there's actually two different possibilities. So I can have a parabola. If k is a 12, that means it's going to cross here. If k is negative 12, it could have crossed over here. And so it touched the x-axis at exactly one point.
That's 2. Negative 12 and total, that'd be 2 points.
Ah, good, good. The question is, well, isn't negative 12 and positive 12 2 points? So if k was a positive 12 in here. If that was it, if k was a positive 12, it would be this parabola. If k was a negative 12, it would be this parabola. So there's really two different parabolas because there's two different equations. Okay, the other part that we get to is now we can go backwards. We finally have the ability, since we learned all the different possible solutions, now what we can do is we can go from solutions and we can actually make our quadratic function that makes that. So we're going to go totally backwards. So find an equation. Notice this is backwards. We would always find solutions. Now from solutions we want to find the equation. Find the equation that would make an answer of t is equal to negative 2, t equals positive 2, and t is equal to positive 3. So you know, first of all, do we know it's a cubic equation? Is that right? Do we know it's going to eventually be t to the third power? Because there's 3 answers here. So how do we do this? Let's go for it. We're going to set each of those set up as equal to. And I don't know why they teach it in this section, because this is really the reverse of factoring. This is factoring completely in reverse. So in my mind, it should actually be taught when you teach factoring, because here's what we do. We're going to add 2 to both sides on this one. So t plus 2 is equal to 0. So I'm going to set each of these guys equal to 0. So subtract 2 from both sides, t minus 2 equals 0. Subtract 3 from both sides, you get t minus 3 equals 0. Alright, so you know that if each of these is equal to 0, and you multiply these guys together, what is it going to be equal to? I heard it in a whisper. Still 0, right? It's each of these are technically 0. If you multiply them together, the product is still equal to 0. So notice that literally this is factoring in reverse. Okay, so then we got to multiply everything out. Then this is the tough part, because one little multiplication mistake throws it all off. So think about which ones you want to multiply first. Should we multiply the t plus 2, t minus 2? Should we multiply the t minus 2, t minus 3 first? Say again? A little bit, yeah. Because something about right here. Isn't this an easy one to plug in? Because something about middles canceling. This is a little formula that we know. Yes, this is t squared minus 4. So if you can do it the easy way, do it the easy way. All right, at this point, then you're done, because now you got to multiply the long way here. So t squared times t makes t to the third. T squared times minus 3 makes a minus 3t squared. Negative 4 times t makes negative 4t. And negative 4 times negative 3 is a positive 12. And no like terms to add together, so we're done. Hey, that's kind of cool. Look at that. We have learned that parabola, that cubic equation, that polynomial, would make these solutions right here. Okay. Why do we need this? Why do we do this here? Because if I know my answers, I can make a formula for it. The fun little example here, I think it's Nebraska. The announcer for the football games for Nebraska State University, what he would do is he would come up during his announcements, come up with actually the formula for the passing of the football from the quarterback, stick man, to the receiver, another stick man. And so he would figure out where the quarterback was. That's me, huh? Okay. He would figure out where the quarterback was, like the 40-yard line. The receiver was at the 20-yard line. And then he would figure out how much time it took to how much the ball was in the air. And based upon the endpoints that he saw, and based upon time, he would, after the announcement, say, okay, the formula for that pass was blah, 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 blah. And he would actually give the formula for that pass. That's just kind of fun. Okay. More real-world example, right? If you want to shoot a missile from one side of the world to the other side of the world, the endpoints are the important ones, right? It's the solutions. I'm starting at this location. I want to go to this location. And as long as you got the locations in there, then you have to plug in and you get yourself a formula that the rocket should follow. Does that make sense? It's the endpoints that are the most important. All right, our economic example on come on. Remember how we were selling the shirt, selling the pants to maximize profits? Well, if we do that, if we know what our price values are, so if it's $2, we're going to put it on sale. When it's $3, we're going to put it onto the clearance rack. And if you can make a formula for it, then you know when you're going to do that. Cool. So then we know in 3 days we're going to put it onto the sale price. In 14 days from now, we're going to put it on the clearance rack because that looks like the most amount of profit. We're good. So we can actually even put a time frame of when that shirt's going to go on sale. Kind of fun stuff. Okay. Of course, got to deal with maybe some fractions here. So how do we deal with fractions here? So I got x is equal to -3/4. I got x equal to 1/5. Can we make an equation that makes that? All right, again, we're kind of running just slightly low on time here, so let me start it here. So set x is equal to -3/4, set x equal to a positive 1/5, and the only thing we don't like, we don't want to FOIL things out with fractions in it. No way. So let's do this here. Let's minimize the fractions or get rid of fractions here. For the first solution, let's multiply by 4, add 3. So notice what we did, we got rid of all our fractions. Awesome. Think you guys know what to do for the second part then. So let's you guys do that. Okay, multiply by 5, and how about subtract 1, and we get ourselves what we want. And now let's multiply them together, set equal to 0 still, and FOIL all that good stuff out. So let you guys do that. A little extra time to do that. All right, and hopefully you guys got, let's see, 20x squared minus 4x plus 15x minus 3, and eventually final answer, how about a 20x squared plus 11x minus 3 equals 0. And there's that equation. Okay, one thing the book mentions, and it's on the homework, but it's not in any one of these matched problems here. So let's jump to one problem that's sort of off the matched problems here. There's an extra here, and I just took one of the homework questions because that was probably make it the easiest one here. So number 51 off the homework. Again, something called multiplicity, and let's talk about what in the world is multiplicity. And again, it's on the homework, just not mentioned in the matched problems. And then of course I took 51 because 51 is actually not part of your homework. Ha ha ha. No, ha 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 ha. That'd be more to give back. Okay, so real quick here, what in the world does multiplicity mean? When you say x is equal to 3, sometimes it could be, you know how when we FOIL things, and it could be like something FOILs into x minus 3 and another x minus 3, right? You have the factors that are the same. So the solution is going to be 3. We're good? But it could be that 2 factors make that happen. Could be that 3 factors. Could be that there's 4. There's a whole chain. There's x minus 3, x minus 3, x minus 3, x minus 3. And so that is called multiplicity. It's the number of factors. Sorry, the number of factors, the number of times the factors occur to make that solution. Cool. So there's multiplicity. Again, it's like a small little blurb in the textbook here. So this is what it means. I got x equals 3. So find an equation that has solutions x equals 3 and x equals negative. Both this one, have a multiplicity of 2. And that little 2 just means there's 2 of these guys. X minus, or x equals negative 3, that means both multiplicity 2. That means there's 2 solutions that make that happen. We good? When we write down the answer, we're just going to say x equals 3. We just don't know how many times it occurred. and multiplicity tells you how many times it should occur. Okay, so let's go for it. The rest is easy here. So subtract 3 here, subtract 3 over here, add 3 over there, and add 3 on the other side. Boom. Okay, and again, let's work this together because there's a little extra little piece I want to show you as well. So if that's the case, tell me if you agree. X minus 3 times another x minus 3 times another x plus 3 times another x plus 3. You can write it like this if you like. So I just want to connect. See where the multiplicity is right here? That's where the multiplicity comes from. Because you're saying there's x minus 3, there's 2 of these factors, and there's 2 of these. Okay, but foiling things out, that doesn't help us to FOIL things out. So the way I would FOIL those out is x minus 3 times x plus 3. So I would put this one together with this one. Anybody know why? It's going to give me a difference of 2 squares, right? Yeah, so I'd rather do this one, and then again, x minus 3 times another x plus 3. All right, and again, we should be able to do this right in one step, right? Because x minus 3, x plus 3 gives you x squared minus 9. And if you have the same thing over here, that's going to give you another x squared minus 9. Good there so far? All right, this one you can FOIL out, or you can, hey, if you have the same thing, don't we have a little formula for that? If we have the same exact stuff, we can, all right, we square the first term. Let's see if we can do this together here. Let's see. X squared and x squared, we square the first term. The sign comes down. And then it's, isn't it x squared times 9, which is 9x squared, and we double it, right? Because the middle now doubles. So 18x squared. And then we take the 9 and we square that one, and at the end it's always a plus, so plus 81. So there's, hey, look at that. We did it all by special forms. We didn't have to FOIL nothing out. That's kind of cool. All done by special forms. Makes life so easy. Okay, 7.4 is actually an easy not easy, a real quick section. Only 4 problems here. So let's actually do that before we get to break here. Then we'll do 7.5 after break. So those that did not print out your matched problems, you got some time to print out the matched problems. Well, let's do 7.5 today too. Okay, 7.4. What is this all about? It is about quadratic equations, but they're in a weird form. I'm going to look at each of the different forms, because sometimes we can something called substitution. Sometimes we can substitute things to make these special forms. Sometimes they come to us inside a problem itself. So most algebra textbooks, they actually call this section quadratic in form. They are quadratic equations, but they're in a form of a quadratic equation. So let's take a look at number 1, and then we'll take a look at each of the pieces here. There's 4 problems, actually three problems, 1 of each type as we go through these here. So we're not going to sort of practice, probably just going to see 1 of each type here. So example 1, let's talk about it, let's think about this here. So notice x plus 3 is being squared, then you got x plus 3 to the 1 power. So notice this is sort of like, in a sense, quadratic in form, because it goes from degree 2, then degree 1, and then no degree whatsoever. We're good? So here's what we're going to do. We're going to do substitution. I don't know why your book likes the y variable to substitute, because all the other textbooks, algebra textbooks in the whole entire planet, they use the variable u to substitute. The reason why you use u is because we do that in pre-calculus, we do that in calculus. We always use the u variable as a substitute variable. Okay, anyways, let's do this here. This looks weird. So we're going to take another variable called y, and we're going to say, okay, y is going to be x plus 3. So if y becomes x plus 3, this whole thing just becomes y squared. We good there? Minus sign comes down. The 2's there. X plus 3 now becomes a y. That becomes a y. And just think of this as substitution. It is the substitution method here. Minus sign. So now, is this a lot easier to factor? Or quadratic formula, or whatever you want to do? Yeah. Okay, two numbers. Multiply to negative 8, add to negative 2. Negative 4, positive 2. Is that right? So y squared minus 2y minus 8 factors into y minus 4, y plus 2. Split them off two different pieces. Solve for each one. So we solved, except we got a little problem. We're not trying to solve for f. We're not trying to solve for y. We're trying to solve for x. And so we go back and say, okay, let's go back over here, and we're going to replace x. We're going to call it substitute back in. We're going to substitute back in x plus 3. So the y becomes x plus 3 again, and then what we do is we do a little bit of work to solve for that. So voila, there it is. So we've solved this equation that looked weird at first. We're able to solve it down to the final answers for it. Okay, I should tell you this. Nick, question or no? Okay. Okay, the only time that we have a problem is, remember in chapter 6. Remember in chapter 6, whenever we're solving square root answers, if we square both sides of an equation, we got ourselves a problem, right? The little alarm goes off in your head, right? If you are squaring both sides of an equation, you have to check those answers to make sure they work. Because you could have just introduced extra answers that were not there originally. Okay? So that's the only time we've got to be careful. Okay. Well, let's do match problem number 1. Very similar to this. Kind of look at this. If you have your textbook open, then you can look at this problem as we do it. All right. So what is y going to equal? Y equals... y is going to equal x minus 2 as our substitute step. Good there. All right, if that is the case, then now that becomes y squared minus 3y minus 10, and everybody's good. Factoring process, two numbers, multiply negative 10, add to negative 3. Negative 5, positive 2. Love that. Too easy, I understand. Solve for the y variable. So how about y equals 5 and y equals negative 2? Back substitute in x minus 2. Add 2 to both sides. X minus 2 equals negative 2. Add to both sides, and yep, got x equals 7, x equals 0. That will solve that solution for x. Kind of interesting, this whole process where you actually solve for y and then you go back to x. In theoretical mathematics, this happens quite a bit, because in math a whole bunch of things are connected, and so what you can do is you can sort of start off with a problem, change it or substitute all the stuff into a different problem, do all the work there, and then bring it back into the original form. I think the way we see it is in terms of like easy example here. How about when we're dealing with some weird fractions here? We can take fractions, we can change them into decimals. We can do the work on a calculator with decimals, and then we can change the final answer as a decimal back into a fraction. Sort of same thing, same concept there. That's kind of what we're doing here. We were originally solving for x. We change it into an equation which we solve for y. At the end, we change it back to a solution for x. Here. Alright, so x is equal to 7 comma 0 or 0 comma 7, whichever way you want to write it. Jump to number 2. Okay, of course, there is a problem on the matched problems. Even the matched problems have problems. So 6x, it should be to the 4th, not squared. So it should be 6x to the 4th minus 13x squared equals 5. Alright, so first things first, before we do anything else, let's set this guy equal to 0. So move the 5 over, So how about a minus 5 at the end there, equal to 0? All right, all yours. What should we use for y? Y should equal, so y equals what? All right, so y, so first of all, let's go for it. If y should not equal x, because if I just plug in a y for the x, I still have y to the fourth, x to the second. That's not good. I need.
Y should equal x to the second.
Well, how about y equals x to the second? You got it. So notice what's happening here. That's what's happening, right? Isn't this really just x squared being squared? And this is really just x squared. So quick little hint here. Y will always equal this little middle multiplier. We good? That's a little trick in here. Y will always equal the middle variable or the middle multiplier to the b. So y equals x squared. If that is the case, is everybody okay with 6y squared now? Minus 13y minus 5 equals 0. Alright, let you guys try it to finish it off. See if you can do it without mistakes. Alright, I'm going to see if I can finish this off too here. The factoring is a little difficult here because let's see, the number of ways you can get a 6y squared is either a 6y times y, 3y times 2y, right? Got those two options there. The negative 5 at the end, that's kind of easy because that's prime, so 1 and a 5. So then I think of this, how can I get a negative 13 into here? Just guessing, that's all I'm doing here. I'm thinking like a 3y over here, negative 5 here, because that'll cause a 15 to be here, right? 15 minus 2, I think that's gonna work out the numbers themselves, right? Because if you do 6 over here and 5, that makes 30. That's gonna be way too much, 30 now. But a 3 and a 5 would make 15. The leftover is a 2. Subtract, gets you 13. I like that. So 3y plus 1, 2y minus 5. I'm going to check. Here's my negative 15. Plus 2y makes negative 13. Voila. Love it. Again, it's the guess and check method, right? You got to just try them, multiply them. Try them, multiply. See what you guys get. So set equal to 0. So subtract 1 divided by 3, we're good there. How about add 5 divided by 2, good there. Except one small itsy bitsy problem. We're not solving for y, we're solving for x. So let's change this up. So y is x squared, so how about x squared is equal to negative 1/3, and x squared is equal to 5 halves, and now let's work this out here. So for underneath the first one, square root both sides. Again, don't forget the little plus or minus. Remember that one? Hey, that was 7.2, wasn't it? This is sort of the square root method of solving equations here. I knew it would come up sometime. All right, I got myself, how about a split this off here. I'm going to put a negative 1 on top, negative 3 on the bottom. Because remember, I still have to rationalize the equations. Remember that? Oh, all that good stuff. So again, I'm going to do the first one here. You guys do the next one here, because they're going to be similar here. Multiply by root 3 on both sides. Finally gets me a plus or minus. Square root of negative 3 over 1. I just want to see the numbers there. Again, you could skip a few steps here if you know what you're doing. Final result. Tell me if you guys agree here. It should be plus or minus I root 3 over 3. Okay, your job. Can you finish this off with y is equal to 5 halves? Changing the y into an x squared. Alright, so looking at this here. 5 halves, square root both sides. X is equal to plus or minus root 5 over root 2. Splitting them off, we good? Rationalizing our denominator by a root 2 on both sides. And how about plus or minus root 10 over 2? Raise your hand if you got that before I did. 4, 5, 6. 6, okay. Improvement by 1. The last time we asked that question. Okay. those are our two answers. Well, no, just kidding. Those are not two answers. How many answers do we have? Yeah, we have 4 answers, right? Positive this one, negative this one, positive this one, and a negative this one. Okay, and the third type that you will see, number 3, probably the weirdest one of them all when you just sort of start staring at it first. And the only question for us is sort of like, is that a good order? Is it really x and then you have the square root of x? Then you have no x. Is that square root really the middle term, or is it really the x that's the middle term? That's kind of what we want to think about. And so the question really is, what is being squared? And so I'm going to do this. I'm going to give you the answer, and then we'll sort of talk about it here. Y is the square root of x. That middle term is it. So now the question is this really the square of this? Is x really the square of x? I think so, huh? Because isn't it right here? Look at this. See if this makes sense. Isn't an x really square root of x being squared? Remember how these two cancel each other out? And so if that's the case, does that make sense there? So this is the middle term, and that is what's being squared to get you that in term. Okay, so got this one, got this one, got this one. So this guy becomes the y. So how about y squared minus y, by definition, minus 12 is equal to 0. Can you factor that down some more? Yeah, let's see. 2 numbers multiplied by negative 12, add to negative 1. Negative 4 and 3 is perfect. Negative 4, positive 3. And solve each of those. How about y is equal to 4, y is equal to negative 3. That's so cool. All right, and our problem is, we're not trying to solve for y here at all. We're trying to solve for x. So let's back substitute this in. So y becomes the square root of x. And what should we do? Square both sides? And not 2, I don't think so. I have to square both sides, right? Not square root both sides, because we already have the root here. We're trying to get rid of the root by squaring, so therefore I get x equal to 16. Remember we're talking about the big nice alarm goes off in your head? We have squared both sides of an equation. It is possible that we have answers here that are not really answers at all. Okay, before we get there, before we start checking things, let's finish this one off as well. Y is the square root of x, and square both sides. And everybody okay with the 9? Cool. All right, our job is we've got to check each of these here. So I'll let you guys check 16, plug it back into the original equation. I want to see if it equals 0. Plug 9 back into the original equation. I want to see if that is going to give us a 0 or not. I got checking 16. I heard that it is correct here. So 16 minus 4 is 12, and 12 minus 12 is a 0. Voila, love it. That is good. And how about 9? Yes or no on that one? Ooh, no on that one, and bless you. 9 minus the square root of 9 minus 12, and we get ourselves a 3. 9 minus 3 is a 6, and 6 subtract 12. I don't think so at all. So we put a slash through the equal sign, saying that it does not equal. What are you talking about? Cross out the 9 as part of our answers, and I don't know what you want to do. Write 16 again, or just circle the x equals 16. Okay, trivia question real quick here. Anybody knows? This one's an easy one, and you can only do this on easy ones, okay? Anybody know which step we could have stopped and we could have said, oh, that's 9's not going to work? Where's the step that we could have stopped and just said, psh, forget this, 9 is not going to work for us? And so, all right, and we could have stopped right here. Right there. There's our stopping point. Why would I not even want to square this? Remember, this is called officially this is called the principal square root, right? It's the positive answer that makes squares to give you x. And so there's no way a square root of x could ever give you a negative answer. Again, you can only work these on easy ones, right? If there's x over here, there's x squared in here, blah, blah, then it's like, oh, forget it. But on these easy ones, you could just cross this out right here and be done. So final answer is x equals 16 only. All right, and word problem, of course, and then we'll go to break here. If an object is tossed into the air, upward velocity of 10 feet per second from a top of a building h feet high, the time it takes for the object to hit the ground below is this guy. Solve this formula for t. Whoa, okay. Again, I'm going to work a little quickly here so we can finish right at break. This is sort of the next level here. We're not just trying to find an answer, right? Actually, we're trying to solve this formula. I want to solve this formula in terms of t. I want t equals something. So based upon the height of the building here. And that's what really, this is really the power of mathematics. If you can create a formula in terms of another variable, you've got answers to a lot of questions in life. So if you can predict when the sale of the shirt should go to the 20% rack or the 10% rack, and which one's going to maximize the most amount of profits from you, and at what time we should do it, and then the second one, it should be a 30% discount or a 40% discount, and which one's going to maximize price, and how long you should keep it there. All these sort of variables. That's why we have people that do number crunching. That's why businesses employ people insurance companies for sure, right? Actuarial work, which I probably almost went into as a college degree. Its starting pay is 90 grand. Within a couple of months, you should be earning about 120, 150,000, and all you're doing is you're sitting in a cubicle and you're number crunching for insurance companies. So, okay, a 16-year-old in the last 5 years, how many accidents has that had? What zip code do they live in? All these sort of different factors. How can you minimize factors for insurance companies? And if you can do that well, you get paid well. So, all right, let's go for it. So again, break is coming up here. So here's what it is. I have a cannon firing off a building, and then it goes, destroys everything in sight. We want to create a formula of time, how much time it's going to take if the certain building is so high. So I want to create a t in terms of h. So there's my formula according to this right here. That's my quadratic formula. I want to solve for t, because t is my variable. H is just a constant that's inside my variable. That's inside the equation. So let's plug in stuff. Again, if we got this, you're doing good here. So everybody okay with b is really 10? Right, or negative 10 in this case. So that would be 100 minus 4 times 16 times negative h, all over 2 times 16. Negative h is the c value right here, because it's all the way at the end. So it's a, b, and c. So the negative h comes in as c. All right, simplifying the stuff inside the radical. How about we got ourselves a 100, but now we got ourselves plus 64h over 32. All right, here's our little problem here. I don't think we've done something like this before. Is there a perfect square that goes into 100 as well as 64? That's our question, because you can't put the h and the 100 together. They don't come together. So what perfect square goes into 100, also goes into 64? Two is not a perfect square. 4 is a perfect square. 9 is a perfect square. 16 is a perfect square. 25 is a perfect square. Which one of those? I heard 4. I'm going to agree with that here. Next step should be 4, factoring it out. So notice the 4 is outside here. 4 times 25 is the 100. 4 times 16 is the 64. I can factor out the 4 now, or not even factor. I can take the 4 out of the square root. Everybody okay with a 2 on the outside? Ooh, and again, question is, can I reduce this? And let's do it the fast way here. I'm going to take a number that goes into 10, 2, and 32 at the same time. 2 is good. So 5 plus or minus square root of 25 minus plus 16h over 16. Okay. Why is that important? Again, launching a missile, you have a certain floor level for radar systems. So it's okay, what height do I need to be so that I can launch the rocket once it hits the monitor on the radar system? Too late. I already made it to the target. And that's kind of what we're trying to find out. How much time does it take based upon the height of the building or the platform that we're firing from so that it gets there in a certain amount of time. So warning systems don't go off. Anyway, stuff like that. Okay, there is a number 5. We are going to skip that one. That little golden ratio stuff, which I think is not all that important.
The last one was the t equals that, right?
Yeah, t. T should come down over here, t here, and t here. So we figured out the time in terms of height. And now you got a formula that says, okay, if I am 10 feet high, how much time is it going to be until the object hits the ground? If I'm 100 feet high, so now I can play with numbers. Any questions on that? All right, and we are done with 7.4.